I thought about talking a lot about Active Directory stuff, and I was like, not to this crowd, because you guys are like awesome. And so I'm going to talk more generally about identity security. I'll focus on the IP part of this. I've been doing this for a little while. My boss just sent me this meme, and I have to say it hurt a little bit. But identity security is something I've been up to for a while. I'm just curious, like, who was in? We'll have an instant disqualifier. Who was working on Active Directory when I started at Microsoft in '95? On Active Directory in '95? Yeah. Yeah. So yeah, you have pre-release type stuff, right? Yeah. So I came into Microsoft in '95, worked on the directory, and so we had MSN. We were competing with AOL. We did, I was the fourth person on Microsoft's internet team. And so we were trying to put an internet-facing version of the member directory for MSN out on the web. And I just shudder to think of the privacy and like what would be currently the GDPR and privacy and data retention stuff that was happening there. But at that point, if you were a customer of MSN, you could be discovered by other customers of MSN because we wrote a SQL thing. And then we were like, ooh, standard's good. Let's start thinking about how to deal with that. And so we started working on this LDAP thing, which I think of as, LDAP has a lot of humor to me. I think if you invest in X500, if you like bother to build that knowledge base, you will defend it to your death because you need to justify the investment. And so, we're all sort of fans of that stuff. But we built that system and released it to some commercial folks. And then true story is Jim Alchin, who was a VP at the time for Windows, came and asked us how many customers did we have that needed the scale that we had for our SQL-based version of Active Directory. So we actually had a fully functioning, essentially Active Directory running on SQL. And that thing would partition out and it could run like 50 million users in a single deployment. And there were 5 customers in the world. And he said, so I can confuse all of my customers to satisfy those 5, or we can kill your project. And so we killed the project. But that directory became the basis for Site Server. Anybody remember Site Server? No? I got a couple, all right, good. And then we went on to do MSN Communities and started getting into consumer stuff. Took a brief detour into the land of .NET. And then any FIM users? FIM? I'm sorry. I was the GPM for FIM, so you're welcome, and I'm sorry. So the joke with FIM was that like many products give you enough rope to hang yourself, but FIM gives you enough rope to like rig a small ship and then hang yourself from the yardarm. So that was that's where I got in, and that was really for me like this time period was awesome because it's when I started getting really involved with this group, and so going to the deck conferences and meeting some of y'all was super special. I went on from there to work on something called Next Gen AD. I didn't put a year by it, but when we were spinning up the directories to support all of our cloud services, there was a debate between doing it on AD LDS or SQL. I was on the SQL side. We ended up losing that battle because of the unholy marriage between Exchange and AD that you can like never ever stop. Like they're just deeply wound into each other. So Murley made I think the right call to base it on AD. And then went off and did identity for Xbox and started doing security and fraud there. And learned a whole bunch about how the fraud ecosystem worked. And then we were relatively successful. So was asked to go work on the Hotmail, Passport, Live ID, Microsoft account, consumer account system. And then went off from there. We were asked to pick up not just that, but also the Azure AD, Entra ID directory system there. We change names from time to time. So that's what I do now. I've been doing it for a fairly long time. We started the security team for identity in 2012 and are still running it today. We eventually picked up internal security and infrastructure security. So that's when I stopped sleeping altogether. So we have to worry about things like background checks and anti-collusion and all the stuff. And so this is the perspective I'm bringing. I will say if one day in cybersecurity does this to you, then after 28 years, I'm like that. There's a point where I don't know, I think I'm fully acclimated to this point, but we're very fortunate to have great customers and great team to work on this stuff. So the thing I wanted to do, using all that is like, okay, as I look back on this insane amount of stuff we've been doing for identity security over the years, like what are the things that don't change? And I struggled with kind of getting down to a few, but there are snarky things I say to my team a lot, and so now I'm going to say snarky things to you, not snark at you, but I'll say them aren't near you, and so this will be a snark-laden probably presentation. But the first thing is that, like, I think we have to, and this is going to sound really obvious, but you know, bad people are going to do bad things. Like, it's just you can't take it personally. It can't be emotional. Right? We see, like, you know, Chinese threat actors doing things like attacking government agencies. You know, we kind of accept that as, of course they are. That's what they do. You see script kiddies trying to do things in a high school. Like, you know, every hacker has to start somewhere. That's where I started too. And, you know, they're going to do what they do. The question here is, like, you know, how is that changing for us, right? And over time, what's changing is that we have incredible collaborative technologies that are making it easier to advance the skill set of these attacks, right? So we can see an attack that is born in the NSA and then turns into, you know, a ransomware technique a couple of years later, or we see the techniques that were used in SolarWinds being turned around and used by Lapsus very shortly thereafter. And part of that is code sharing that happens in collaboration. So even our own tools like GitHub get used by attackers to both develop and publish tools, right? So we see this volume. And then the other piece of this that's interesting is that, and this will be thematic throughout the talk, but like, it's a wonderful world that we live in, that we have done like so much in terms of, we have created identities for people and machines and allowed people to interact, or digital entities to interact in ways that mirror society, to the point where most things that are happening in society now have a digital identity backing, right? So think about whether it's power plants or medical care or retail or whatever, it's all interwoven into this stuff. But what that means is that the value that's available in the surface area that's available for attackers is going up exponentially, right? And so we have this exponential growth in tool capability, exponential growth in surface area. And so I think that it's really important for us to, like, you know, and here I will try not to be too naggy, but you know, my refrain at Microsoft is very often, like, we just have to find ways to punch through and get the message out that, like, we're not going to have exceptions for every executive who doesn't want to switch out their old iPhone. Like, we're not going to, you know, we have to find ways to get ahead of these curves, because the volume of attacks is growing, and so being really a little bit disciplined about what we allow people to do is important. So when we think about dealing with scale, like, just to give you a sense of what's happened, this is a true story that I stole this slide from Pam, but the data was mine. Give it to her for a talk. We had this true story that we started measuring how many attacks were happening. And this is really one particular kind of attack, which is a high volume, high failure rate password attack. So it's sort of indicative of list cleaning and password spray and these sort of high volume attacks that are coming through. And we deal with you know, many billions of these a month and many hundreds of millions a day. And so we measured, and originally the number we measured was like, I don't know, it was like 75 million a day. And so I was like, well, it'd be cool to talk about that in terms of seconds, because it's like more rockable. And so we said, okay, let's do the math, and it turns out it's like 579 a second. And then we went on, we like reevaluated a couple months later, it was like 849 a second. And then we went again, and it was like 1,021 a second. I said, look, let's just say 1,000 plus. And so that's when Pam's talk snapped. And then we were like updating the numbers for this year, and we got this, and I'm like, oh no, that's wrong. And I don't resource that data, that's wrong. Like, the data should come from my team. My team, like, is the authority for that data. So no, that did come from your team. I was like, that's not right. So I went to my lead data scientist. I'm like, what's up? And he's like, well, you know, that's the number. And I said, but like, we need to be looking at this in terms of, like, we can't look at a spike. There's always these attacks that come and they spike us. And we're like, that we shouldn't be looking at a spike. He's like, it's not a spike, it's the last quarter. It's like, it's been running like this. So over the last year, we've been running 6,000 plus a second in terms of password attacks, password-based attacks. Like, so it's like this just constant barrage on us. And what we're looking at is things like, if this is an IP address that you've never logged in from before, and that IP address is showing a lot of failures, or if the IP address is associated with an attacker, there's a bunch of different things we're using as metrics. If you're like navigating directly to some pages that's way deep in the system, you know, there's a bunch of things that we trigger on. But this is north of 99.9% precision. So like, basically all of these are attacks, right? And we're just blocking these out of hand. So you don't see this stuff, but just to give you a sense of like how intense the script kiddies and that kind of stuff is going, right? You have to be in front of this stuff. So when we look at like what causes, this conversation around like, like why should we care? Like, so what? An account get compromised, right? Well, that's, goes directly for probably the big buzzkill is ransomware. I think most of us have been in this position of, like, as security people, of having this kind of debate about the phantom specter scary thing that could happen, please give me some money, versus the, oh my God, there's a sales opportunity right there, right? And we're kind of in this balancing between like, okay, the business versus security. And so it's like productivity versus security. We've all been caught in that. But I think that like when you look at ransomware, that's like a serious productivity buzzkill, right? It like wipes out your business. And so you got to start getting to where you can have a conversation about like, no, this stuff is super, super important. So, we know MFA is the way to deal with this stuff. We did a study that we actually went through a scientific process and like got peer reviews and stuff on, just so that we could like kill any arguments about whether MFA works. So for, the vast majority of attacks, like MFA is massive risk reduction for account compromise, right? So I would say MFA every single time. And yet 30% of users are using MFA. Right, and so that's after I think we've been campaigning on this since 2017. Right, we've been pushing super hard on MFA adoption. In 2017, Nitika Gupta and I measured this and presented it at 0.7%. So yay for 30%, right? But we're not where we need to be yet. And so like when we think about like just doing the basics, like the basics hygiene stuff remains really important. And what I'd like to do, hopefully, is I know you folks all know this, but helping you equip yourselves for some conversations with other people in your organization who are like, but it's disruptive. It's not disruptive. Like everybody does this all the time, and disruptive is ransomware, right? Okay, so the other thing to think about in this space is, we have pretty good, I think we have actually very good detection in our system, or risk prediction in our system. So, like, we have an interesting problem with the kind of the global health thing around getting people to take action on risk predictions, which is that we spent as an industry a bunch of time trying to convince the world that what they needed was a SOC. Like cool kids have a SOC. And so you go buy yourself a SIEM, and then you go, so a security integration platform, right? You go pump all your data into that thing. You go hire yourself a bunch of people that like look like the cool people on NCIS Cyber and have multiple large monitors and wear dark clothing. And listen to goth music, and I feel seen. And then then you've solved your security problem, right? By definition, that problem is after breach, right? Anything you're detecting in the SOC is post-breach. Damage is being done, right? And so what happens is we have these predictions, like we say, given the elements that we're seeing here, there's a possibility that this is not your real user, this is an attacker. Those predictions don't run at the kind of so the SOCs, by the way, they're all overwhelmed. There's way too few personnel. And so they're looking at, I need a 100% guarantee that if I look at something, it's actually a problem, right? And so then you hand them a prediction that says, well, there's about a 50% chance that this is a hacked account. And they're like, well, I'm not gonna look at that because that's only 50%, I need 100%. Like I need for sure to get meat. But if you have the chance to say, hey, let's re-authenticate you because there's about a 70% chance that you're dealing with a bad session, and you could stop the ransomware for the cost of a user doing this very low friction thing. Or you say, hey, we found your password on a list, go change it, right? Go clean that up. The math is pretty clear, right? You don't want to accrue a bunch of security debt where you have a bunch of accounts in the system that are probably hacked, waiting to be exploited. But if your goal is to wait until the SOC can look at every one of those things and take action on every one of those things, you're just accruing massive amounts of debt, especially when you demand this perfect precision. So the other thing is, like, along with the basics of security hygiene, like using MFA every single time, every single authentication, right, is also this idea of look at the predictions that your system is offering you and act on them. And so instead of thinking, we have to be very careful not to impose friction on this small group of hoodie-wearing, goth music listening people in dark rooms with big monitors, right? Don't worry about that. Just get the average user to do like a little tiny something. If you don't retire picking on passwords a little bit, if you don't change passwords with any kind of a policy, which you should not, the data is very clear that that's actually harmful to your security posture. but you do change it when it's discovered leaked. The average user will change passwords every 2.5 years, right? That's not a lot of friction. Change your password every 2.5 years. That's the average user will hit that because we found their password on a dark website, right? And so you can kind of shift to this idea that where we have predictions that have lower precision, which is to say they may have some false positives, use less friction, but still have some friction. Like check ID at the door, right? It's not that big a deal to do it. All right. Second constant, life isn't fair. We were recently discussing how the Princess Bride, see, I think people in here could probably quote Princess Bride, right? But some of us anyway, but like my kids can't. And that's, life isn't fair, princess. Anyone who tells you different is selling something. So life isn't fair. Like you're dealing with a situation that is, you're defending an estate that has a center of gravity, right? And that center of gravity is some number of years in the past. Right, you've been deploying systems for like 20 years, right, in an organization. And so on average, the systems are 10 years old, right? And the center of gravity for your system is older, right? Attackers don't deal with that math, right? They basically say, hey, that attack stopped working, throw it away. There's no productivity, but wait, I need that system for finance or for quarterly reporting or whatever in hackerland. In hackerland, you just kind of go, oh, let's get the new thing. So you're defending this estate. And you're essentially, your ability to project change is logarithmic, because the more technical capability you accrue, the slower you will go at changing it, right? Whereas attackers are mostly working on collaboration and sharing technology, so their growth methods are exponential. So we have this basic problem, right, which is we're dealing with this huge disparity, and the disparity is growing. And so this will kind of get back into this question of like, how do we get deterministic about the controls we have? How do we do good isolation and containment? And one thing that we have found useful to start talking about at Microsoft is like this concept of fraud economics, right? The economics of the system, like where are we losing money? So I did this little piece of math, which was just fun and an example, right? But if we can say like, all these things are substantiated down below, but if 80% of breaches are attributed to identity, right? And 75% of organizations will be breached in the next 12 months, and the average cost of breach globally is 4.35 million. In the United States, it's 9 million. But let's go with the global number. Then you can kind of predict a loss due to an identity breach in an organization, any given organization, of about $2.5 million. That's like a pretty large, hit, right? Okay, the average user meaning the average security posture across all of our organizations carries a risk of compromise of about 0.5%. So, if you do that math, you can kind of say there's about $10,000 in incurred security risk per user if you don't take action to protect them, right? Now, I talked about the 30% adoption of MFA before. That 30% adoption is interesting in that when we look at the average compromise rate across our whole ecosystem of that 0.5%, right? So 1 in 200 accounts will be compromised every month, right, across our global ecosystem. But MFA has grown from 0.7 to 30%, and that 0.5% hasn't changed. So what's actually happening is that the remaining people, the people who haven't done MFA, are now absorbing more and more of that cost, right? So what's happening is attackers are, essentially they're just accelerating the attacks. We're seeing the volume of attacks and the incidents that go up, right? So if you're not using MFA, you're starting to move into this population that's like, more and more picked on, right? So now we're up into like, I think it's like 0.9% if you're sort of 1 in 100 if you're not using MFA, right? And then the rest of them are much lower. So the next constant here, told you there'd be some snark. And I really had to redact my snark. I can't say all the things I would say, by the way, I love people. I'm like a huge, like if you know me, I'm like totally interested in people and love individuals are wonderful. I think Tommy Lee Jones has this quote in Men in Black, right? Which is, individuals are great, but people are panicky animals and you know it. And so like, this is a quote from a colleague of mine at Microsoft, and we were talking about the problem with manual operations and manual security operations. And he said the problem is that people are 1 to 2 flop processors with suspect microcode. Which is awesome, right? Like you might be able to do a couple of division problems in your head in a second, right? So that's 1 to 2 flops. And like you will not do it predictably, and you'll probably deal with my talk by getting an extra drink tonight, and then that's suspect microcode, right? And so we keep thinking that we can deterministically train these non-deterministic state machines, right? And so we're like, I know, I'll put up posters in the elevator, and then people will stop getting phished. And it's not going to work ever, like ever. I mean, like, stop. It's been 30 years we've been trying to do it. Like, stop, right? Little fold. We don't even have like lunch tables to go to anymore, right? So, the issue here is like we also have, I think, more people who think they're familiar with tech, and again, like our tech systems, their bias is, the midpoint of when they started learning about stuff. Somebody told you once to use passphrases, and then that would make things okay. It doesn't. Right? Somebody told you once that a password manager was the answer, but it's not, right? Like, and so the question is, how do you get to a system where you're not dealing with this? And this is, by the way, a true and recent quote that I got. So Jan Baker is one of our, was one of our CXP folks. He's awesome. We did this, I'll talk about it in a second, but we did this rollout for number matching in the authenticator. And this was an actual piece of customer feedback, which is, it works really smoothly, but you should autofill the number. Anyway, so we have to make it impossible to fail, right? So we talk a lot in our team about the pit of success. And we're working really, really hard in a bunch of ways to make that happen. But an easy place to kind of highlight this is we look across like all the different kinds of credential attacks we have. Another stolen slide from Pam. Like everything up to MFA attacks, like we'll talk about these nasty boogers up here in a minute, but everything up to here, like we can actually mitigate, right, with the right kind of credentials. And so you have lots of different authentication methods you can pick from in Azure AD. And if you're doing strictly on-prem, which I think not likely that too many people still are doing only on-prem, but you have several of these choices like cert-based auth as well, right? The question of how are you authenticating people for different modes is important, but where we see so many of the same password attacks getting through, so many of the same phishing attacks getting through. We have a recent attack that you may have heard about in the press that the same people who did SolarWinds are doing. We now call them Midnight Blizzard. I don't know why. We used to call them Nobelium. We like to change names. But Midnight Blizzard, same actors that did SolarWinds, are doing Teams-based spear phishing. So they create a Teams like contact to a user, and they get into a conversation with them like, hey, I'm doing maintenance on your account. It's all the same old stuff, just a slightly different method. You can also just call somebody on the phone and do this, but people will generally fall for it. So how do you make it so they can't fall for it? You have to go to like actual credentials that are designed for that. So we've been doing a bunch of work to make it possible to essentially specify, knowing that like we have to do rollouts, we have to do incremental deployments of these things, right? So we have conditional access policies that let you roll out phishing resistant auth. But I would just say it's like super important that we get to phishing resistant auth if you want to get serious about this stuff, because people are going to get phished. People are people, right? So anyway, different strength policies for different things. If you're involved in federal customers, the EO requires the phishing resistant auth. Like super big fans of that. I think we haven't said phish proof because somebody will figure out a way to get tricked. But we have several methods that can do phishing resistant. And then the authenticator itself is not, by the way, currently phishing resistant, right? Because phishing resistant basically is about saying, even if you wanted to help the bad actor, you couldn't, right? The credential just cannot be released except for to the right relying party. But we did a bunch of stuff in the authenticator, like the maps and showing what user agent you're coming from and what service you're going to and where we think you are. And people still like to get phished here. But we're trying more and more. So like the latest things we're doing, we just released the suppression of the notification. So you won't see a notification in cases where we see risk. And so you'll have to go and pull for it. You have to go into the UI and say, hey, I want to see my notification. And now we're doing an interstitial. We're working through an interstitial page, which is going to say, no, really, you're being phished. Like, hey, And unfortunately, because there are cases where like IP location can be wrong and detections can be wrong, you can override that. But we're trying to get more and more breaks in place for the person who's like, I'm talking to this person on Teams, and then my app says, Like, no, 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 this is phishing. And then the person on team says, no, don't worry about it, it's okay. And then the app says, no, it's not. And then the person on the team says, no, but it is. And then you say, okay, and then you enter your code anyway. But it's because people are people, right? That's why we need to get to the next part, which is we have to get to like these phishing resistant credentials. So passkeys is a really important step here because like we have to normalize the new credential. Like for everybody you know that uses computers, which is everybody you know, the password is the normal way you sign into stuff. And it's terrible. It's like, it's awful. Right? And I will not do another 45-minute rant on that, but we have to get away from it. And having a really normalized on every device you're familiar with, there's a way to sign in without a password, and the major vendors are all supporting it. And so Windows, Android, iPhone are all supporting this to try to make this like really normalized. Really good news for us is that, and for enterprise people, so the downside to this, if you're familiar with FIDO, part of the promise of FIDO is like, hey, the key material never leaves hardware. The private key material never leaves the hardware. But for this to work in a consumer space, we actually have to be able to go from phone 1 to phone 2, or I lost my phone, but I recovered it. So all those scenarios have to work. So the consumer stuff, all does support roaming the key. But both Apple and Android have given us plugin points, just like they have plugin password managers, so that we can use the existing authenticator deployments to provide phishing-resistant authentication in the passkey paradigm. And this is like giant for us. This is huge. So we can give you all the same like protections and adaptive UX and all that kind of stuff. And most importantly, we can convert the 150 million or so. By the way, the authenticator is the #1 way people authenticate in Azure AD today. Like it's like now tipped other systems for that. So if we can get all those people to convert to being phishing resistant, it's like a massive, massive win, right? So that's kind of where we're trying to go with that. All right, next constant. I really struggle with this one in terms of trying to make it like actionable for you. But I have been saying this casually to my team, to my executives for at least, I don't know, 12 years. I used to sit next to a guy named Dave Treadwell who ran the identity division for a while. And every morning he'd come in and he'd go, hey, Alex, how's this going? And I would say, it's worse than you think. And it's a good mental model to be in, right? When you're in this business is like, you know, you're this like assume breach part, like we talk a lot about like, okay, what are the systems we're doing to verify the requests and how do we restrict users from doing things they're not supposed to do? But this last one is, I think, underserved in terms of what are the automation investments and the other investments we're making to assume that bad things are going to happen. And like the sophistication that exists, the budget disparities that we've talked about, the user complicitness with the attackers, all those things are like making this harder, and then we get tired, and then we get complacent, and then that's what the criminals are relying on. Right, so there has to be this kind of constant drive to say, wait, it's still on, like we're still playing. If you're not seeing it, you're not looking, like go find the bad guys. And so preparation is the big thing here. And just to, I'm not known for like, I don't know, I was so cheerful when I left Alex's talk. It's not really my brand. But like, we had this cool slide that Simon's used to have about digital transformation. Basically, people who are embracing digital transformation are having like wonderful sailing, and the people who didn't have sunk to the bottom in terms of business, right? But the other thing is that like, when we do digital transformation, we create more data. We have more processes accessing that data. We have more PII to handle. We have more systems combining that data. We have more points of human touch. We have more real world systems that are digitally controlled and controlled through digital identity. So we're massively increasing attack surface area, right? And so like, while we used to live in this wonderful world where we had like, we're the identity people, we will give you access. We will create low friction, right? Here, like you come to the company and here's your laptop and it's already got your account on it because we're the identity people. We give you things. And then you had these bastards in security, right? And they would come along and they're like, no, you can't have it. Like no access. And the wars like used to wage on this. For people who are in identity groups, like who's working for the CISO now? Yeah, anybody? A couple. Oh, I'm surprised it's not more. But yeah, so a lot of identity groups are moved into security now. And so we're starting to see a shift here where like these worlds are coming together. And what I would say is that in the world where you actually believe it's worse than you think, you actually want to make good friends with your security teams, right? Do they know where your federation servers are? Do they know which accounts to watch out for that are particularly sensitive because they can change the rules on your federation servers. They know who your domain admins are and to like watch those accounts specially. Like, do they know the physical hardware that those things on the physical networks? Because very often these teams are separate, right? You have an endpoint or a device security team separate from your network security team, separate from your identity security team. Bringing those things together, right? Super, super important. Having processes that let you move fast when you have that breach, not if, when you have that breach, right? Is really, really important. If you're assuming breach, right, then you want to get into that place. So, are you exporting and preserving logs, right? Are you ensuring not just least privilege access, but least standing access, right? Like actually revoking. We had a big, vigorous argument yesterday at Microsoft, which I probably shouldn't share, but I will anyway, about how draconian to be, and of course I'm on the very draconian side, about revoking access. Like, hey, you haven't used it in a month, it's gone. Whatever it is, whoever you are, whatever app it is, right? It's just gone. Like, having systems that automatically take access away. Isolation, so this is boy, I can't do this show of hands. Just think to yourself whether you would raise your hand for this. Who can, while doing administrative tasks on a domain controller, quickly look something up on the web on the same machine in the same session? Who can send a quick email to somebody asking for some help? Who can reach out on Teams and ask for that help? Wrong, don't do that, right? Because all these points of contact, that's like malware, that's phishing, so isolation of these environments, these are the crown jewels, right? So I grew up in a military family. My father was an Army officer. And we used to talk about how the military is about preserving democracy, not experiencing it. You are about providing seamless access, not experiencing it, right? Like as directory administrators, your job is to create isolation boundaries around your crown jewels, right? And that means that you do not have the same convenience you're offering to your users. All right, so what's in the incident response plan? So when we talk about being ready for breach, right? One of the big things about being ready for breach is if it happens, what is your plan, right? And so the incident response plan is the thing that we do. This is just I'm gonna give you a few pages from our book on this stuff. This is the thing that we do. Like we have, who are all the contacts you'll need to get in touch with? Who are the people who can make quick decisions about the business? Like, do we turn off the service? Do we, stop providing? Who can do the escalation? What are the escalation engagement? Who's your on-call? Where's the operational guidance for the service? Where do you find the logs if you have to do investigations quickly? Like getting this stuff done up front is important. I'm a big fan also of the communications plan, right? Like decide what you're gonna say ahead of time so you can talk fast. We have, like at Microsoft, we have templates. So when we have an incident, we can snap in blocks of text to essentially get quickly, you'll notice the wording is similar between incidents, right? Because we have that. So there's a bunch of things that are in here. What exceptions have been granted? That's a really important thing for your security team to know. You go, we have this all the time. Oh, don't worry, everybody who accesses mail has to do MFA. Really? Yeah. Okay. Well, so I find this log entry where this person didn't. What's up? Oh, well, except for the people that have exceptions, right? So do you document your exceptions? Are you tracking them? Are you burning them down? Which leads us to this. All right. So remember I said it's worse than you think? So, and I promised I would talk about this. So we've had a, okay, tangent. So have you ever seen the movie Airplane? The old, yeah, okay. So here's my tangent. I was hiking in Moab in March and I injured my knee. And it was a pretty bad injury. And I decided I was gonna to go easier on my knee and to try to avoid surgery. I'm trying to lose a lot of weight. So I go on this draconian diet, which I'm still on, which is why I'm no fun to hang out with, which includes not drinking. So I stopped drinking. And then a couple days later, this shit happens, right? And so it's like the airplane, I picked the wrong day to stop sniffing glue. I definitely picked the wrong day to go on a diet, but hey, I've stuck with it. I'm still not drinking. It's just calories, but man, it hasn't been a couple of months. So let's talk about a little bit about what happened here. I'll tell you what I can tell you, and I assume we'll have a few questions after. So we have two different identity systems. We have a consumer identity system, which is the one that supports Xbox and Skype and Minecraft and stuff like that. And then we have the enterprise identity system. And over time, those systems diverged, and the key management systems for them diverged. and we have then we have new classes of apps like GitHub that you want to be able to say, well, actually, I want to talk to the consumer person because I have a high school kid checking in code, or I want to talk to the enterprise person because I have a Microsoft developer checking in code, right? So I want to be able to deal with both. So we have these hybrid applications. So we bring these two kind of systems together as far as an application is concerned, so that you can have applications that can deal with both. And to support that, we come up with this thing called the converged endpoint, or the common endpoint. And it's a publishing endpoint for the public keys are, so for if you're validating the token, right, you're gonna use the public key to check the signature in the token. And we publish both public keys on the same endpoint, right? Which seems great. And we published a bunch of documentation. Here's how you decide which key to use for which scope, and here's the validation you need to do. Prior to this time, we had published a library, which is cleverly called validate token, right? Which helps people validate tokens cryptographically. So it just does the crypto work for you. So it doesn't look at scope or expiration. It just kind of says, well, this public key decrypt that signature and validates what's in there. So that thing pre-exists. Unfortunately, we had an issue where one of our services, which is obvious from the text on the screen, looked at that validation library, assumed that was all they had to do, and was accepting enterprise claims signed with a consumer token. Right? And so that's what allowed this crossover thing to happen, was that validation error. So that was quick and easy to fix. And then we have the second issue, which is, okay, how did the consumer key get out there? And that's one I can't talk about in this forum. If you are a customer of ours and you want to talk about it, I can talk to you about it, but I can't talk to you about it in a big room. But we have a good beat on how it happened. And I think this is a case where I actually want to paint this. I'll talk about the case a little bit so you understand the basics of it. And then I actually want to talk about it in context of the it's worse than you think and the preparedness stuff. So anyway, so this thing happens, basically, we know when they started the attack. They started the attack on May 15th. The attack wrapped up when we rolled the keys on the 27th. The attack was detected by a customer, and the customer reported it to us on June 16th. Okay, so that's kind of the timeline around this thing, and this is all on our public blogs. The actor is a China-based actor. We say China-based because we know for sure that the actor is functioning in China, but we don't know who's sponsoring them for sure, right? So it's China-based, not Chinese. We're not making assertions about that, but we know who they target, and they target government organizations in the Western Europe and the United States, and they're particularly interested in like economic legislation, things like sanctions, government agencies, and that sort of thing. Why do we think they're working out of China? Well, they work from 8 to 5 in China. Or maybe they work from 2 in the morning till 10. I mean, my kids, that's their normal time, right? So like, you don't know for sure, but like this is the time span. The IP addresses are egressing mostly out of Korea, China, Singapore, so nearby. We have they're communicating with each other in Chinese. We have text intercept and that sort of thing. So we have tremendous amounts of intercept on this actor. We've been tracking this actor for a long time. We have a robust organization called Mystic, which tracks about 1,500 persistent threat actors in either organized crime or government-sponsored agencies around the world, right? And we maintain TTPs and IOCs on each of these actors, and we look at how they talk to each other and how they coordinate and all that kind of stuff. So in this case, Storbo 558 is a China-based unattributed actor, and they basically started exfiltrating email data from 25 organizations and some correlated consumer accounts on May 15th. On June 16th, we were notified by the customer of something they had seen on June 15th. We have a team called DART, which is the on-premises, like they're the guys that helicopter in and essentially help customers. So DART went on site with these guys and figured out what was going on, got that over to my team and the office teams to start the investigation. And we hypothesized on June 27th, we didn't really have hard data, but having not had success with other investigation lines, we hypothesized that it was stolen key material on June 27th and rolled the keys. Key roll takes a while. It has to propagate across the world, and the applications have to pick up the change. And so because the actor was only present in mail, we had very good triangulation on that. We further blocked in the mail system specifically anything signed with that key. That key was an expired key. It was basically we keep one key in backup position so that if we have to do an emergency disablement of a particular key, we have another key in backup position. That key was a backup position key for the consumer system. It wasn't being used by any of our systems to sign tokens. And for that reason, it was very, very easy to find actor activity in the logs once we knew what we were looking for. We could find that thumbprint of that key and we knew for sure what we were dealing with. So anyway, so we blocked it across the board for all possible people, enrolled it by July 3rd, right? Now, I mean, I'll just say, like, wow, that sucked, right? Like, there's a lot to not be happy about here, but there are some things to be happy about here, right? We had our incident response plans in place. We had our communications and our escalation plans in place. We had our customer engagement plans in place. We had the teams knowing how to talk to each other, right? If you compare this to SolarWinds, in SolarWinds we had 144 organizations that were impacted, that most of which were impacted for north of a year before detection due to on-prem compromise. And eviction in some of these cases is still going on. Like there are a few of these organizations that have still not successfully evicted the actor, right? And you compare it to this case where we had essentially the same sort of attack at a different scale, where we were able to respond in a couple of weeks, right? And contain that to 25 organizations in a much shorter time frame. Like there's evidence there that the preparedness and the kind of drilling and the communications and all the pre-work helps you out a lot, right? So anyway, we mitigated. I'm not going to go into this slide too much, but I think that like the important, and we'll save. Like I'm happy to answer questions about this either after the talk or later. But I think there's a really important lesson in this, like for all of us, which is, do you have your incident response plan? Are you saving your logs? Are you truly assuming breach? Are you really assuming, hey, it's worse than you think? Something is happening in my system. I'm not sure what yet, but I need to get ready for when I find out, right? And that's a super important lesson. All right. So chapter 2 is around change. Accelerating change is a constant. So just kind of flipping it around real quick. You have a million laws like Moore's law and 1,000 derivatives of it. But all the indications in terms of attack velocity, attack complexity, surface area are all indicating that change is happening faster. And what I'm coaching my team on now is to think of what they do not as like incident response and threat response, but as the stewards of a system which with increasing efficiency handles incident response and threat response, right? Like how do you think about like really changing the game to say everything you're doing is not about saying, how do we mitigate this attack, but how do we mitigate attacks like this faster in the future, right? And so this constant investment in the infrastructure around attacks is really important. And to do that is super hard in a world where your team is already overwhelmed and you're like, you're buried with security incidents or tasks or grumpy people, but it's really, really important. So I wanted to take a page from, this is a person on my team named Tia, who's fantastic and owns our post-incident response program. And just kind of an idea of like how this stuff can work. And by the way, never shared this stuff outside of the company before, so you're the first. Tia was thrilled that I was going to share it with you, though. She was really excited. So on the left, what you're seeing is just the first page of a 6-page template. And the template asks questions like, hey, was this introduced by a change? Was it a regression? Was it detected by a researcher? Was it detected by an attack? But it'll also get into things like, okay, what went well as we responded to this incident? What did not go well as we responded to this incident? What could have gone better? The 5 whys is like at least 5 hard questions. Why did that key leak? Why was the key in a position where the attacker could get access to it, right? Why did it take a customer telling us that there was an issue here, right? Like hard questions, hard biting questions. Okay, ask yourself those questions. What are our learnings as a team around this? What are we gonna go do about it? And then out of this comes a bunch of things. So if you're looking at this graphic here, right, basically we have our own red teaming, pen testing, external attackers, researchers, they're all finding problems in the system, right? Like that's what they do, and that's by design, right? And then we also have attacks. Where we have attacks, we have to treat those differently, but every flaw we find is assumed to be an attack until exonerated. So if a researcher calls us and says, hey, I found a flaw in your system, we're gonna say, okay, an attacker has found that, let's go find evidence. And we have to prove, we have to like not be able to find it, right? So that's part of the process. What's the mitigation? Like quickly make sure that we stop the flaw, whatever it is, and then you get into deeper things. So this investigation happens, and then there's this PIR process, which is that document, and it generates infrastructure repairs, right? product repairs, and process repairs. And all of that stuff goes into the pipeline, changes the security controls that are used to develop software, and then new software comes out, which is, because humans are 1 to 2 flop processors with suspect microcode, still flawed, right? And then we find the next set of flaws, and then we go through the wheel again. And we continuously do this. This is like just all the time. And then just what this is cause analysis. So once a quarter or so, we look at all the things that have happened and say, okay, what are the commonalities? What are the things that are happening here that we can detect and fix? So if you think about this in terms of the security instance you're dealing with, this is a very copyable pattern. You may not be quite as extreme here. This is a large identity system, you might say. But this kind of rigor, this kind of thoughtful, and it really is all about letting go of there's no defensiveness allowed here, right? You can't, this whole idea of we're a learning organization, learn it all, don't know it all. You have to just be, yep, we screwed that up, how do we fix it? Right? You have to be willing to move through that stuff. All right, and the last topic around this is things that we're doing in product. And I think that my ask here is, even if you're not using these, think about how you can emulate some of this stuff. We have these insanely hard change management process because people are people, and they get scared, and they get grumpy about change. Right? How do we accelerate the rate at which we can push changes into our user bases so that we get more secure behaviors, right? And the problem here being that we don't have perfect prediction of how users will, say, respond to a Teams message that says, please enter your authenticator code, right? So given that stuff is happening, how do we do this? So we have some examples here. Secure by Default has been a super successful program. We're now pushing this out to existing organizations that have shown us that they don't care about security, basically. They've never touched a security setting ever. Right? And so we have a bunch of, starting in 2019, we started rolling out to all existing tenants the security defaults, which are things like you can't use legacy auth, you have to use MFA, you have to use MFA to access certain secure elements, that sort of thing. And then we started rolling this out to existing organizations because that's a huge base of organizations. North of 90% of organizations that are existing organizations are retaining the settings. So we're basically just turning on MFA one after the other. So in our big 30% MFA stat, right, fully 10% of that now is stuff we just did for people. We stopped asking. We're like, okay, look, just take it, right? And it's surprising in some sense that you can go do this and you get very little backlash. Again, retention is excellent. Customer support calls are basically nil. We just say, hey, we're going to make you safer. We're going to do this thing for you. We're doing the same thing with the authenticator, pushing people off of SMS, which is very insecure. It's 40% less secure than any other method for MFA, onto the authenticator. Same thing is happening. We're having tremendous success in this. It turns out that you can be more aggressive than you think, probably with your user bases. I know, but that, it's always the executive guy that's but not me. Exceptions are bad. Policy templates, trying to make it easier to adopt new policies really fast, getting this down to one click is part of the goal. It's still hard. I know who's doing anything with conditional access now? Okay, good, cool, awesome. Thank you. Anyway, so we're trying to make conditional access much easier to use, and then giving better analysis tools here. But the problem will still exist for the vast majority of organizations who are not you, right? In some sense, the fact that you are an organization equipped with people like you says that you're in a massive outlier set. Right, you have genius identity people running your domain controller. Most people don't, right? They just are I'm a dentist, I don't know, I just want mail, right? No, I'm serious. That's the majority of customers, by vast majority, right? And so they're never going to see a graphic like this. For the people that are geniuses like you, we're trying to make it easier. But then we're also doing a bunch of things just essentially the consumerization of identity security for all those organizations that don't want to think about it. We had this unfortunate thing where we had basic yes/no approvals for the authenticator because we wanted to make it easy to use that. We found out that about 1 in 100 people would approve an authenticator request unsolicited. So we swapped it out for this pick from the 3 numbers. And we found out that 1 in 300 people would successfully approve an authentication request unsolicited. They would just guess. And then we said, okay, what if we make you type in the numbers? And then you stop guessing. You're I don't know, it's too hard. So it went interestingly, it went down to 0. We expected it would go to the next divisor, but it went to 0 because people stopped guessing. So we basically defeated this MFA fatigue attack by doing this. And it was a crazy day, a crazy battle that we fought. Because I said, no, we're just going to turn this on. Like, the other method is provably insecure. We're not going to allow provably insecure technology to remain in the system. So we're going to get rid of it, and we're going to go to this model. But what my customer wants a switch. Like, no, they don't get a switch. Like, and this was kind of a radical thing, but to give you a sense of kind of where we're going on the team now, we're pushing harder and harder on these things that we're like, no, we know this is insecure. We know this is bad posture, right? And because it turns out when you get hacked because of this thing and you wanted the switch, you still yell at us. You're still, it's like, well, why didn't you let me have the switch? So we're moving this direction. This is a place where we would love collaboration and feedback from you guys, like any, because we're testing boundaries here to figure out how do we move the posture. Like we're having definite impact. Like the security defaults in this program have both had massive reductions in compromise for the people we've done it for. But we also recognize that this is your shop, not our shop, and like we're here to help you. So anything you can do to help us find those boundaries. Most of the customers that I'm talking to are like, yes, we definitely want more help. And then there's sort of a boundary line where you don't go past it. So anything you can do to help us understand that better is great. Detections are another place where we have a gajillion detections and growing, and we're like constantly evolving and innovating in detection space. But at the end of the day, if you have to change your policy every time we have a new detection, it's a huge problem, right? What we need to do is just say there are categories of risk. There's the risk that the credential is compromised, the risk that the user is an insider attacker, et cetera, and that all these signals accrue to those risk factors. And then you can set a policy that says, hey, if this is an insider attacker, go do this thing differently, right? And so that's an area that we've been working on. But even with these detections, several of them are machine learning driven. And like I have at this point, I think it's safe to say I have a deep background in supervised machine learning. I've been running a supervised ML team since 2012. And holy crap, can it be hard to understand what a classifier is telling you? Because it's looking at like 130 elements of the login and then using a mathematical weighting between those elements to decide what's what. And like, then I'm gonna go, hey, this is anomalous. You're gonna be like, well, what was weird about it? Like, no, trust me, it was anomalous. Like, but what? Like, no, it's like, it's too hard to explain, but it was bad. Like, and so it turns out people don't like that very much. And so it gets us into this next thing, which is that we've hit this inflection point with large language models where I can actually have one computer interpret another computer, right? So I can have my classifier system, my supervised machine learning system has a classifier. It's spitting out this huge matrix of factors. And then I can plug that into an LLM, and the LLM can tell you, well, it's just that you were logging in like a couple hours after your normal time, and you were 30% farther away from your normal location, and you were trying a new browser. It's just, we can kind of get those elements together and actually explain them in plain language. So we're hoping this helps us a lot. LLMs are going to be transformative here in a bunch of different ways. Like, how do I explain to you what the hell the collection of your conditional access policies actually does, which is a top request from customers. Like, just tell me what the system's doing, right? And I can actually now, we can start getting into that, where we have these complex systems. We can say, okay, the summary of your policies is blah. And these things you can do, by the way, today for yourself if you feel like it. The GPT and hand it there's an API to dump your conditional access policies, and you can feed that into ChatGPT and tell it to spit it back to you in English, and it will do it. And like, we've done that experiment, it works great. So we're trying to build that kind of stuff into the product to make it easier, and eventually get to a place where we can essentially make this, kind of more of a business conversation, where understandability and configurability is much, much better in most cases. However, that opens a whole new can of worms, right? We get into this fun stuff. Like, what happens when we have attacks that are using generative? What if I can spearfish every single person in your organization perfectly using their own mail contents and your organizational structure and your mail templates to make it exactly genuine and maybe even interactive, right? Because I have an LLM, so I've dropped the cost here. What happens if I perturb the generative systems by inserting prompts to make it do crazy things? If you've read the New York Times article as an example, there's a bunch of defensive stuff we're doing there. And then of course, we've built all of our stuff around this idea of like crypto. What happens when we start seeing use of quantum and Shor's algorithm to start breaking crypto? So we are in for a heck of a ride, right? And we should have like lots and lots of fun going forward. Cryptography, sorry, cryptography. Although they're related, right? So I've reviewed like literally thousands of threat models over the years. And how many, anybody here review threat models? Anybody do threat models? Go get there. Okay, cool. So if you're threat modeling, how many times have you done a threat model, for the three of us that do them, that basically say transport security is handled by SSL? SSL's been broken for 10 years, even without Shores. With Shores, it's like a joke, right? So like things like crypto agility, the ability to roll your crypto, change your data at rest, like building, it gets back into that whole building for agility. All right, I think I'm right at time, but we're seeing hands, so here we go. Okay.
Yeah. All right, Sunny here. When you talk about the adoption of MFA, right, does this also entails the on-premises applications?
So what we have visibility into is cloud applications and connected on-premises applications. So if you did like if you have a user who's doing like in a hybrid environment, they're doing, say they have hybrid AAD join, and they sign in on their device, and they go like to us and they get a token, and it's a strong auth claim, then they would count. And the chances are pretty good that if you're sending them with Windows Hello, that they'd also have that strong auth claim on premises, but we don't have visibility into it. So we're only measuring the stuff we can see, which is the cloud stuff.
Going back to MFA, looks like this is a very simple thing anyone can do to prevent these sort of things. But what do you think, what is the business inhibitors of adopting this? Still is 30%, though it's growing, but like, is that funding availability or education of the businesses, and what do you think?
I think there are two major factors here. I'll go with the easier one first, is the vast majority of organizations that came up, set up, didn't have MFA, didn't ever think they needed it. You know, you're a off-roading mechanic in, I'm picking on specifically an event I just did, Auburn, California, you know, like you have a small shop and you just have a couple of dudes that are doing email. Like you're not thinking about it at all. So there's a huge amount of that. There's a huge amount of student populations. Student populations are a huge problem in terms of fraud and compromise. And so, those kind of like forgotten populations or forgotten organizations that they just don't have the staffing to go and think about the policy. So that's one thing that I think is, in some sense, easier to deal with, and some of our policy rollout stuff that we're doing now will help with that. The other place where we have is, I think, the insidious part of the problem. And the insidious part of the problem is that for the vast majority of people, security threats and digital security threats are a thing they haven't experienced personally. They haven't fallen to ransomware that they know. They don't have attackers in their system they know about. I mean, like, the China-based actor that was targeting the organizations that we just helped, had they remained undetected, there would have been no day-to-day experiential change for any of those users, right? Like things would have gone subtly different at the negotiating table because data was available to the other side of the negotiations, right? Like that's all. Like espionage is one of those things where, like, if it's being done right, you don't feel it, right? If you have low-level transaction fraud, you shouldn't feel it. Like so these are all things where people don't feel any pain from it. And then on the other side is like, then I start to roll out MFA and I get 10 help desk calls and I immediately feel pain from it, right? Like it's like the thing that I can sense and viscerally understand versus the thing I can't, which is why I like to call it ransomware. Like ransomware, you're going to feel it. If it happens, you're going to feel it. And people are terrified of ransomware. There's an interesting thing where ransomware has become one of the primary movers for MFA adoption, because when you look at the complexity of what I'm asking you to do, in some sense, have incident response plans, have PIR processes, like have very strict policies, like track your exceptions and burn them down, have no standing access, like all that stuff, that's hard. Or I'm going to go buy insurance, so if it happens, I'll get my money back, right? And so what most organizations are choosing to do is to buy cyber insurance. Cyber insurance policy is like, well, this will cost you, $1,000 per user per month if you have MFA, or $100,000 per user per month if you don't. And then they go, oh, I need to turn on MFA now. But it's actually now it's a board decision coming down saying, save us money on insurance. But I don't really care. I'm happy if it's happening. We're trying to get it to happen. But I think that second part is really what kills us, is that we have the knowable, quantifiable, deterministic friction of changing our policies, even if they're from, you'll end up in a better state. Like for sure, the overall user experience is better with like the authenticator than it is with passwords, right? And the end state is better, but the change process induces friction, and that's a it, right? Versus the risk you're carrying is like, well, but it hasn't happened to us yet, and so people defer it. That's it.